All right, guys, let's go ahead and get started. So I already ordered the vouchers. I did that about like an hour ago, so they should be coming in probably like by tomorrow night, and I'll assign them to you guys right when I get them. They'll be on your account. I'll also send you an email, and then the certificate of completions will also be sent out Friday. So just a quick reminder. So today we're going over domain 3. Let's go ahead and let's just take a look at these actual exam objectives for domain 3. Bring up the Network Plus exam objectives. So this is going to be network operations. So what we're going to go over today is going to be processes and procedures. We're going to go over monitoring technologies. Kind of they have a lot on here, and a lot of these monitoring technologies, you know, this could be a week-long section in itself, just going over SIME. That could be a month-long, training course going over SIM or SIME. So again, high-level stuff here. As far as like network engineers in particular, like SNMP still used a lot. This is like SolarWinds, Zabbix if you want an open-source solution. So I'll go as deep as I can over that. But again, we don't want to get too bogged down in the weeds with it. This will be a quick one, just going over disaster recovery. Then we'll go over IPv, pretty much IP network services. So that's DHCP, DNS, and then the time protocols, so like NTP, how we get our timing. Then we'll finish off today by going over VPNs, which we kind of touched on the first day. We're just going to look at another slide deck, kind of going over the site to site, and then client to site VPNs and split tunnel versus full tunnel. And that'll be today's lesson. So let's go ahead and jump right into it. So starting off, it's going to be going over stuff that's kind of boring but very important in our day-to-day as network engineers. If you ever have done NOC operations, you know how important this is. So it's going to be domain 3.1, explain the purpose of organizational processes and procedures. And we're going to start off by going over documentation. Okay, so documentation is essential for maintaining a well-organized networks. It helps network administrators, engineers, and other stakeholders understand the network's architecture, troubleshoot issues, and make informed decisions about future changes. So a important line in there is a stakeholder. So documentation, yes, it's good for your engineering team. So when you're working with your engineering team, you have different levels, and you have to explain to a junior network admin how the packets flow. Or even when you're troubleshooting yourself, you have to say, okay, what hops do I have in between, and what could possibly be stopping this traffic? If you have good diagrams, that covers like 90% of your troubleshooting, knowing how the signal flow or the data flow is. But beyond that, if you ever have to explain an outage or explain architecture changes or explain the architecture to a non-technical stakeholder, sometimes a simplified diagram will just be able to show them, like you're in a Teams meeting, hey, check this out. Here's what you're trying to hit. You don't need to explain to them it's a Red Hat Linux server running this app that's containerized and has Kubernetes scaling out the containers, right? You don't have to explain that. You can just say, hey, you're trying to get here. Here's your computer. And right here, this is a device that we have to bring down to make sure that you can reach the service you're trying to reach over here. And it's right in the middle of the path, and that's why you're gonna have an outage for this 2-hour maintenance window, right? So kind of explaining to, again, the non-technical stakeholders, the diagram can be your friend. So we have different types of diagrams that we're gonna go over here for the Network Plus exam. So we have a physical diagram. So these diagrams represent the actual physical connections and layout of the network devices. This could be going over where patch panels are, where those IDFs and MDFs are, where physically things are located, right? So Fast Ethernet 01 is going to Fast Ethernet 01 from switch 1 to switch 2. That's a physical diagram. Not necessarily that you need like IP addressing or, oh, this is, a port, this is LACP port channel. You don't need all that. This is just like where things are going physically and where they're located. So you could have a physical diagram that says this switch is located in room 210 on the second floor of building 468 on our compound, right? It could be something like that, like where it physically is sitting. And logical diagrams, this is going to be the flow of data. So like you look here, I consider this a logical diagram because it's like, it's not showing me where these sit, but it's showing me how all these connect off to my like distro or my core switch here. It's showing me my vMotion subnet, how these are all interconnected, and they probably all have SVIs here, and how they're all talking, right? It's just logical. Logically, how are these connected? What VLANs are they part of, and what subnet are they a part of? So that's a logical diagram for like our campus network. That's a good campus network logical diagram. Though sometimes logical diagrams can have a certain flow to them. Like when I make diagrams, I like to, if I'm doing north to south based traffic, that's how I like to make my diagrams. If I'm diagramming out a data center rack, I like to actually have the rack, have the physical connections, but then also logically say, okay, look, this switch 1 is stacked with switch 2, so that's a logical switch there, and this is doing a VPC or a port channel to my wireless LAN controller in this data center rack. So I like to do both if it makes sense, right? At least try to say, this switch is in room 1, floor 1, building whatever. But then we can also logically put IP addressing and VLANs that are coming off there. So it really just all like depends, right? What kind of diagram you need for your purposes. And then rack diagram. So this is something specific to a data center rack. So if you have really, even if you don't work in data center technologies, you work in an enterprise, there's going to be comms closets. There's going to be there's going to be racks that even have an access switch and ups, and that's it. But if you want to look at that diagram from like physically how things are cabled up, or excuse me, how they're actually racked, we just call that a rack diagram. So this is a visual representation of how equipment is physically arranged within the network racks. And this should be accurate. Like this right here looks like this server that I'm hovering over is 3U. You see 1U, 2U, and 3U. So that's kind of also what I like to see in my network rack diagrams is the sizes, the width, the height, and the depths. Then we have cable maps and diagrams. So cable maps are used to document the physical connections between network devices. You may say, what's this between this and a physical? This could go deeper, right? This could say, hey, this is hanging off, patch panel, whatever your naming scheme is, and it's connected to wall jack, whatever your wall jack naming scheme is, right? So it can be a little bit more detailed than just a physical diagram that says switch located here, out port 01, to switch located over here on fast Ethernet 01 on switch 2 in this building or this room. It's a lot more detailed about the specific cabling. A lot of times you'll see people that are dedicated to cabling large campus networks, they'll have this, right? They'll have their cable maps. That's all they care about. They just want to know where things are cabled. They don't need to know that, hey, OSPF is going through this single mode fiber run from a couple miles across our campus. They don't care. They just want to know how it's ran, it's underground, what hops are along the way, things like that. Okay, and then just a network diagram. So you may be saying like, yo, what is the difference between physical, logical, and then you're telling me now there's something called a network diagram. So I think what the Network Plus is trying to say is that a logical diagram, that's a kind of an umbrella term. Like I could have a logical diagram as an electrical engineer, technically. I could have a logical diagram for servers. I could have a logical diagram for cloud resources. But when they're saying network diagram, the way I kind of interpret their exam objectives is this is the network, our layer 1 through 3, right? Where is for network engineers, what are our network diagrams? Maybe we don't care about the clustered ESXi environment or the containerized Kubernetes cluster in the cloud when we make our network diagrams. That could just be server 1, and that's an IP address. And as long as we hit that node cluster IP, that's all we care about. So maybe we don't dive deep into our cloud infrastructure and, diagram that out. As network engineers, we kind of, this is it right here, right? This is it. And this file server could be, way more complex than this, what I'm labeling here, but it doesn't matter to us, right? We don't need to see the fiber, the ice scuzzy between the SAN and the compute resource in that file. So maybe we don't need all that. We just need it, hey, this is an IP address. As long as I can ping it, or as long as I can hit it with like SMB or NTFS or NFS, that's all I care about. So I just need to know my network. So that's how I interpret when they say network diagram. So network diagrams come in several layers. Layer 1, the physical. Layer 2, the data link. So layer 2 diagrams focus on communication between devices on the same network segment or LAN. It's your layer 2, right? You're switching. Then layer 3 shows the logical connections between devices, focusing on IP addressing, routing protocols, and how data is forwarded. I kind of think when we make diagrams, like you do all three pretty much, right? Even here, this is kind of all three. It's my physical, my IP addressing, and then I have a switch there. And I could put like VLAN information in there too. Okay, asset inventory. So asset inventory, there is no like one size fits all for this. Like asset inventories can be different between enterprises, whatever your standard is. You could use IPAM to help you with this. You could use a software to help you with this. This could be a long Excel spreadsheet. This could be a content management database that has a little asset inventory template for you. But what it does is it just lists the hardware, software, licensing, and warranty information. That's it. It's just a way to actually literally put on paper, put on digits our inventory, what we have, what we don't have. That's physical, that's logical, that's even like end of life, end of support stuff like warranty. It's even licensing. Like the firewalls I work with on a day-to-day, they have licenses that are assigned to them. It's like Cisco Smart licensing, right? So maybe that's something I want to put is that, hey, no, this license belongs to this serial number of this firewall, and it's not interchangeable. So maybe I want that on our asset inventory. So more documentation. So IPAM, IP address management. This is the process of planning, tracking, and managing IP addresses within a network. So I have a screenshot up here of NetBox. That's an open source solution for IPAM that's very popular amongst enterprises that want to automate. This is essentially a source of truth for all your subnets, your IP ranges, and all your prefixes that live on your enterprise. It's one centralized place we can all go to get the truth about what IP addresses are assigned where on what devices, and it can be very complex, it can be very simple. We have SLA, service level agreements. So we should have a centralized place where we have all of our SLAs for the engineering team to understand. So saying, hey, this is what our contract looks like with this vendor, and this vendor. Especially if you're in a multi-vendor environment where there's maybe lots of pre-sales, post-sales system architecture working with for the equipment you buy from them. And maybe we have SLAs with VARs, right? Authorized resellers. So, it's just important that we have all the SLAs that we may need with cloud service providers and that the whole team understands these SLAs or knows where to go read them. Dealing with a little wireless, we could have wireless surveys or heat maps. So a wireless survey is just showing the signal strength of your wireless access points, where there could be interference, where there could be refraction, and this could be a heat map, or a wireless survey, in my opinion, should show you 2.4 gigahertz map and then a 5 gigahertz map, and then show you where you're losing coverage, where things are overlapping, where there could be poor signal strength, so that you know where to adjust your access points. All right, awesome. Now let's go over domain 3.1.2. Let's jump in here. Okay, so in 3.1.2, so finishing up domain 3.1, we're going to go over lifecycle management and change management. Some more of the processes that we're going to have on an enterprise. Okay, so domain 3.1.2, explain the purpose of organizational processes and procedures. So again, going over lifecycle management and change management. Okay, so lifecycle management. As a term, just lifecycle management, this could be for data, this could be for physical hardware. And I mean by data is like, oh, we have to retain this sensitive data for 25 years. Lifecycle management just says, when are we going to get rid of things, or when do we need to upgrade things? When do we need to move on to the next version? That's all it is. So it refers to the practice of managing various stages of an IT asset's existence, from deployment to decommissioning. Now, obviously, right now, we're going to talk about something specific in lifecycle management, and that's EOL and EOS, end of life, end of support, and this is going to be vendor-based, right? But there is some lifecycle management for like your certificates, which you're not getting from a vendor, right? That's just X.500 certificates you put on web services to do HTTPS. But that's all encompassing, but in this section, we're going to be a little bit more specific for the Network Plus exam, okay? So, end of life versus end of support. These often get confused, and sometimes even vendors confuse them. So sometimes a vendor may say end of life and they mean end of support. Now there should be a clear delineation, and that's what we're going to teach you. That's what CompTIA describes, a clear delineation between end of life and end of support. And for the exam, I want you to understand the definitions I'm going to teach you here. So end of life is the point at which a product, usually hardware or software, is no longer manufactured or sold. So what does that mean? That means, let's say Cisco Catalyst came out, and this, I don't know if this is true. Maybe I should have looked it up before I started, but let's just say Cisco Catalyst switches came out in 2020. And on January 1st, 2020, their end of life date was 7 years from then. So that means by 2027, probably a little bit before then, Cisco as a vendor will no longer sell or manufacture Cisco Catalyst switches. They won't sell them anymore. Meaning you cannot get a new off-the-shelf from the manufacturer, from the factory, from the plant, a Cisco Catalyst switch by 2027, January 1st. That's the end of life date. End of life is the vendor who created that software or hardware will no longer sell it Doesn't mean you can't go buy it from a VAR. It doesn't mean that you can't go buy it from a reseller, but that Cisco manufacturing plants, there will never be another catalyst made there. That's what that means. Okay? That's all it means. So what does that mean for support? What does that end of life day have to do with support? It actually has to do with nothing. The day you lose support, the day the vendor stops fixing bugs, stops patching vulnerabilities, is called the end of support date. This refers to the point when the vendor is no longer providing technical support, patches, or security updates for a product. So although they may not manufacture or sell it, and I get it, resellers that have their own warranties, that have their own support, I'm talking straight from the vendor. The end of support date is when they say, hey, we'll not take another Cisco attack case, we'll not, we'll not have any more software engineers patching bugs. That's end of support. So end of support date could be a little bit longer than the end of life date. Some vendors may do them at the same time, but that's the difference between the two. End of life is we're not manufacturing. On our shelf, the vendor shelf, you're not going to see a brand new software or hardware come from us. That doesn't include resellers, right? And then end of support is we will no longer fix anything to do with this product. We're done supporting it. It is, I don't care. Get it off my, get it off my email. I ain't answering nothing about this product no more. Okay? That's the difference. Okay, software management. So managing software across a network environment includes handling patches, updates, and ensuring that software components are secure and functioning correctly. There are so many different ways, guys, to do software management. So many third-party apps, so many third-party products, a lot of products straight from the vendor. I've used Splunk before, SIME, to track Windows updates and Windows bugs. Windows has their own products at CCM. They have Microsoft, not Intune, that's for users, but they have their own Patch Tuesdays, right? So managing software really depends on what third party you're going with, but there should always be some sort of fundamental understanding that as an organization, based off our stakeholders' requirements, based off our risk appetite, based off whatever we determine, however we see how important updates and bugs and patches are, we'll start a cycle for that. So patches and bug fixes. Patches are software updates that fix known vulnerabilities, bugs, or add enhancements. So like Patch Tuesday for Microsoft. If you've worked in an enterprise for a while where you're for profit, meaning that systems being online, third-party apps that sales, marketing teams, whatever your teams use being online directly correlates to your profit, you know as an IT team that when a new patch comes out, you're not applying it right away. Unless it's like from the management, this is a level 10 vulnerability and we need to patch it because of things beyond your, you don't even, we got in meetings from the government, whatever the case, the only time you see a patch applied right away is in those severe cases. But in organizations where it's for profit and your revenue generating functions are third-party apps running on your operating systems, your user laptops, typically patches are going to have a timeline. It comes out June 1st. We have 60 days to apply this patch. And we're going to test it in our sandbox environment, see what it breaks. If it doesn't break anything, we're going to roll it up to the change management board saying we're going to apply this patch. Here's how it affects or does not affect the architecture. Here's the test we did. They approve it, and then we apply that patch, okay? Managing operating system updates, it's kind of the same thing, right? Test it out, roll it out when you want. And same with firmware. It's pretty much what I just described for patches and bugs fixes is going to be kind of the same flow for OS upgrades and firmware updates. And again, this is really organizational dependent as well. Decommissioning. Decommissioning refers to the process of safely removing IT assets that are no longer required or have reached their end of life. But again, this is all based off your organization as well. If you want no end of life ever on your environment, that's your guys is the way you do things in an environment, then okay. Then you probably decommission right away. If you say, hey, we have sensitive data on here, our decommissioning process is a lot longer than just resell, clear the flash and resell. We may have like a destruction process. Then decommissioning may be a little bit more difficult or a longer process. Okay, change management. So change management is something that's done in pretty much every enterprise, and it's a systematic approach to dealing with changes in your environment, whether they're small, whether they're changes to the larger architecture. It goes through some sort of process to go through senior engineers to management to stakeholders to bless off on that change, give you a timeline to when to apply that change, and then everyone signs off and boom, the change is done. And along the way, we've done our tests. We have rollback plans, fallback plans, and maintenance windows. request process tracking and service requests. Now, if you ever worked like IT help desk, this is like all it is, right? Tracking tickets, tracking requests, elevating them, putting notes on them. So in change management, the request process tracking is essential for documenting and tracking all changes within the network. And a service request refers to a formal request from a user or department for a service or change within the network. Every enterprise may have a different way they do this, whether you use Jira to track all your projects, or you use GitHub to do your change management in a CI/CD pipeline, or you're old school and you write Word documents. You send that to 5 different management teams, and they all look at the Word document, make their changes, and don't have the same one, and then it's crazy. But that's a way to do it as well. And then you have a change management meeting once a month. However you do it, there's always going to be some sort of request process and service requests that are going to be tracked. Okay, configuration management. So product configuration is the live environment. So how do we configure our live environment? And when we make changes to the live environment, how do we do it? Well, typically in an enterprise, we don't, unless we've gone through change management boards. We have a maintenance window. Backup configurations refer to the maintaining of, I don't really need to read the whole thing. A backup configuration is exactly that. We have a known working config and we back it up. So in like my enterprise, we do something called, they call it get-alls, but essentially it's just, let's go get the running configuration from all our devices, put it in a shared drive, and that's a script we run every day, right? Or once a week. So we always have those good backups. So if something goes down all of a sudden and we're like, what changed? And we don't have good logging or auditing on our system, we can go take that good running config, maybe paste it back in there, and then all of a sudden it's up. It's like, okay, maybe someone did something, they don't want to fess up to it. Then the baseline or golden configuration is a template of the ideal standard configuration for network devices. So this may include just the basics, already hardened configuration, all the VLANs you may need, how the trunks are supposed to be on a trunk, everything that you want to happen. And then obviously we apply this baseline configuration on our devices. And then because it's not always one size fits all in a network, maybe we have a sales member working in the marketing department's office area, so we have to add a sales VLAN on that switch, which is not part of our baseline, but it's what we have to do, right? But that's what it is. It's just a good, clear reference for troubleshooting and for maybe when we do our provisioning of a new switch. We put the golden template on there, give it to the spoke office, we get on site, and we're like, oh, you guys actually have a NAS here? Well, that means I have to open up a port for a shared drive, right? So that's kind of how a golden configuration or baseline goes. All right, awesome. So that was domain 3.1. I got 5:55 my time. So let's come back in 10 minutes. I'll put 10 minutes on the board, and we'll reconvene at 6:05.